Assalamu alaikum. Welcome to our presentation. This presentation is about coordinating system. This presentation is presented by Abdul Khalek Meshkat, Abdul Qayyum Mahimudundar, and Mahfuza Akhtar. And our presentation is presented to our Honorable Method Instructor Muhammad Jahed, Lecturer, Department of Electrical and Electronic Engineering, University of Chittagong. The topics that will be discussed in this presentation are coordinating system, orthogonal curvilinear coordinates, Cartesian spherical, polar, and cylindrical coordinates, change of axes, and transformation of coordinates. The first two topics will be discussed by Mahfuza Akhtar. Please, Mahfuza Akhtar.
Assalamu alaikum. My name is Mahfuz Akhtar and I will discuss about coordinate system. A coordinate system is a system that uses numbers or coordinates to determine the position of a point or geometric element. The basic coordinate systems are one-dimensional, two-dimensional, and three-dimensional systems. One-dimensional coordinate systems give a distance from a given point or origin in one direction. One-dimensional coordinate systems are better known as number lines. Two-dimensional coordinate systems give the distance from a given point or origin in two directions. Three-dimensional coordinate systems give the distance in three directions. Now, I will discuss about Cartesian coordinate system. Cartesian coordinate system is used to locate a point in space. We work on Cartesian coordinates in a two-dimensional space on a plane, but we can also use them in spaces of three or more dimensions. Cartesian coordinates used to specify the location of a point in 2D plane or 3D space. A Cartesian coordinate system in a plane has two perpendicular lines, the x-axis and y-axis. In three-dimensional space, it has three perpendicular lines, the x-axis, y-axis, and z-axis. Now I will discuss about one-dimensional Cartesian coordinate system. The Cartesian coordinate system for one-dimensional space consists of a line. We choose a point 0, origin on the line, a unit of length, and orientation for the line. The orientation chooses which of the two half lines determined by 0 is the positive and which is negative. Each point P of the line can be specified by its distance from 0 taken with a negative or positive sign. Now I will discuss about two-dimensional Cartesian coordinate system. A Cartesian coordinate system in two dimensions, also called a rectangular coordinate system or an orthogonal coordinate system, is used to locate the position of a point in a plane using two perpendicular lines. Two perpendicular lines are named as x-axis and y-axis. Points are represented in the form of coordinates x, y in two dimensions with respect to x and y-axis. The two axes of the coordinate plane are the horizontal x-axis and the vertical y-axis. These coordinate axes divide the plane into four quadrants, and the point of intersection of these axes is the origin 0, 0. Take two number lines x, x prime and y, y prime. Place x, x prime in horizontal and write the numbers on it as we write in the number line. Similarly, place y, y prime in vertical and proceed writing numbers on it as we write in a number line. Combine both the lines in such a way that the two lines cross each other at their zeros or origins. The horizontal line x prime is called the x-axis and the vertical line y prime is called the y-axis. The point where x prime and y prime cross is called the origin and is denoted by 0. Since the positive numbers lie on the direction ox and y, ox and y are called the positive direction of the x-axis and the y-axis, respectively. Similarly, ox prime and y prime are called the negative direction of the x and y-axis, respectively. Point 3 marked by green dots in the graph, the horizontal distance in 2 units in positive x direction and the vertical distance perpendicular from the reference horizontal axis in 3 units in positive y direction. And hence we denote the point as 2, 3 in coordinate form and it belongs to quadrant I since both are positive. Similarly, we can extend the same idea to other points marked in the graph as well. Now I will discuss about three-dimensional Cartesian coordinate system. The three-dimensional Cartesian coordinate system consists of three axes, the x-axis, the y-axis, and the z-axis, which are mutually perpendicular to each other and have the same units of length across all three axes, similar to the two-dimensional coordinate system, where the point of intersection of these three axes is the origin 0, and this axis divides the space into 8 octants. Any point in space is represented with the coordinates x, y, z. Now, our groupmate Mahi will start the next topic. Please, Mahi.
Thank you, Mahfuza. Assalamu alaikum. I will discuss about spherical coordinate system. Spherical coordinate system, denoted as r, theta, and phi, is the coordinate system mainly used in three-dimensional system. In three-dimensional space, the spherical coordinate system is used for finding the surface area. These coordinates specify three numbers: radial distance, that is represented r in that figure, and polar angles that is represented by theta, and azimuthal angle that is represented by phi. But our editor makes a small error, but theta and phi will replace each other in that figure. Please pardon our mistake. As we discussed, the radius measured from a fixed origin, the polar angle is measured from an imaginary point near to the exact location, and the azimuthal angle on a reference plane passes through the origin. The radial distance is also known as radial coordinate. Apart from the radius, the polar angle could be mentioned as a collatitude, zenith angle, a normal angle, or inclination angle. R is the radius of the system, theta is the inclination angle, and phi is the azimuthal angle, as you can see that in the figure. Now, I will discuss about polar coordinate system. The polar coordinate system is a two-dimensional coordinate system, a system of coordinates in which the location of a point is determined by its distance from a fixed point at the center of the coordinate space called the pole. By the measurement of the angle formed by a fixed line, the polar axis or the positive x-axis, and a line from the pole to the given point. The polar coordinates of a point are given as r and theta, where r is the distance from the pole and theta is the measure of the angle. As you can see in the figure, that P is the point and r theta is its polar coordinate system. Here is the point P is a R from the origin O, and it is at an angle of theta. The reference axis, I mean the x-axis. The origin is called the pole, and the x is called the polar axis, as you can see. Now, I will discuss about cylindrical coordinate system. A cylindrical coordinate system is a three-dimensional system, coordinate system. Cylindrical coordinates can be defined as set of three coordinates that are used to locate a point in the cylindrical coordinate system. In two dimensions, the location of a point can be denoted by both Cartesian and polar coordinates, as we discussed. When the polar coordinates are extended to a three-dimensional plane, an additional z coordinate is added perpendicular to the xy plane. And these three measure together from cylindrical coordinates. The coordinates describes two distances and one angle. Here, r is used to denote the normal polar coordinate. It is the distance from the origin to q. Here, q is the projection of the point P in the xy plane. Theta is the angle between x-axis and the line segment that is drawn from the origin to q. This is known as the azimuthal angle, is measured in radians. Z represents the third cylindrical coordinates. It is the same as Z Cartesian coordinates and denotes the same distance of P to the xy plane. Thus, the cylindrical coordinates of P are r, theta, and z. Change of axis. There are three kinds of change of axis: translation of axis, rotation of axis, and translation of rotation of axis. These topics will be discussed by pardon me, I will discuss it. The translation of axis, shifting on origin. If x, y are the coordinates of a point and the origin is shifted to h and k without changing the orientation of the axis, the new coordinates is xy of the point will be given as x plus h, and y plus h. It is very simple because we discussed in our previous classes when we are 9 and 10. Now, this is a typical topic. Rotation of axis. Let Pxy be a point on the xy plane. As you can see, let the axis be rotated about origin by an angle theta in the anti-clockwise direction, as you can see, theta. Then, with respect to the rotated axis, the coordinates of P, x prime and y prime will be given by x is equal to x cos theta, x prime cos theta minus y prime sin theta, and y equal to x prime sin theta plus y prime cos theta. Transformation of coordinates. This is a very important topic. Cartesian coordinates to polar coordinates. As you can see, there is in that figure, there is a right triangle that will be created by point x, y. If we draw a perpendicular line to the x-axis and connected with the point, then we can see there is an angle theta, and r is the distance from the origin between point and the origin. So here you can say r square is equal to x square plus y square, and theta is equal to tan inverse y by x. Now, polar coordinates to Cartesian coordinates. As you can see, to convert the polar coordinates r theta to Cartesian coordinates xy, the steps are follows. X is equal to r cos theta, y is equal to r sin theta. Simple, because there is a right triangle in that figure. So we can easily measure the x and y. Now, cylindrical coordinates to Cartesian coordinates. To convert cylindrical coordinates r, theta, and z to Cartesian coordinates set x, y, and z, the steps are as follows. When the polar coordinates r theta to Cartesian coordinates x, y, the formulas are x is equal to r theta, y is equal to r sin theta. We discussed it. Now, cylindrical coordinates are polar coordinates extend into three-dimensional space by adding the z Cartesians. Look at that figure. Thus, cylindrical coordinates can be expressed as Cartesian coordinates using the equation given below. As you can see, x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. Cartesian coordinates to cylindrical coordinates. To convert Cartesian coordinates x, y, z to cylindrical coordinates r, theta, and z, the steps are as follows. As we know already, r is square equal to x square plus y square, and the theta is tan inverse y by x, and z is equal to z. There is no change in the z. Spherical coordinates to cylindrical coordinates. To convert spherical coordinates rho, theta, and phi to cylindrical coordinates r, theta, and z, the steps are as follows. By using the figure given above, applying the trigonometry, the following equation can be derived as r equal to rho sin phi, z is equal to rho cos phi, and theta will be the same in the both coordinate system. Now, cylindrical coordinates to spherical coordinates. To convert cylindrical coordinates r, theta, z to spherical coordinates rho, theta, and phi, the steps are as follows. Rho is equal to r root over r square plus z square. Theta is the same as before. Phi is equal to cos inverse z divided by root over r square plus x square. Now, orthogonal cardinal coordinates. The surfaces u1 equal to c1 or u2 is equal to c2, u3 is equal to c3, where c1, c2, and c3 are constants, are called coordinate surfaces, and each pair of these surfaces intersect in curves called coordinate curves or lines. If the coordinate surfaces intersect at right angles, the cardinal coordinate system is called orthogonal. The u1, u2, and u3 coordinate curves of a cardinal system are analogous to the x, y, and z coordinate axes of a rectangular system. Thank you. This is our presentation, and please pardon our mistakes if we done anything. That will be all. Assalamu alaikum warahmatullahi.